Hi, and welcome to the 7th episode of a base building tutorial series where we're building a small base builder-like game using SpriteKit and SwiftUI. And today we're finally going to dive into SwiftUI. So, where we left off last time is that items are now visible. So you can see we have a stack of wooden blocks here. So they're visualized now in the game. So what are we going to do today? So integrating SwiftUI with SpriteKit is actually quite powerful, and there are two ways of doing so. The first option, if you have an existing SwiftUI app, then you can add SpriteKit to it using the SpriteView view. And the other option is, and that's the one we're going to be using today, is to add SwiftUI to an existing SpriteKit app. And you can do that using an NS hosting controller. This also works on iOS, but then it's a UI hosting controller, but they basically function the same way. So our goal for today is I want to be able to show some game state in the UI to really demonstrate that the integration between the SpriteKit world and the SwiftUI world is working correctly. And we'll do so by first doing some basic SwiftUI integration. So we'll do a sort of hello world-like view to show that we can indeed show SwiftUI views in SpriteKit. And then we will be connecting the SpriteKit world and the SwiftUI world using a ViewModel. And finally, we will show that this is working correctly by implementing a small hover over tile information so that you can see what kind of tile is more or less under your mouse. So let's get started. First, open Xcode, and I want to start by creating a new group called GUI, and in this group I'm going to add a new file, and this time it will be a SwiftUI view, and we will call the SwiftUI view GUI. By default it creates a sort of hello world view, and that's actually good enough for now. So integrating SpriteKit and SwiftUI we need to do from the view controller, and we can do that by first importing SwiftUI and then adding stuff to the viewDidLoad method. So the first part is all about SpriteKit. So let's create a label here where we're adding the SwiftUI stuff. And the first thing we need is we need a GUI, and this will be an instance of the GUI struct. Then we need a UI controller, and this will be an NS hosting controller, and it will use the GUI as the root view. And then we will add the child UI controller. We do need to do a bit of additional setting up. So let's take the UI controller, its view and its frame, and we will set it to the SpriteKit views and frame. So basically they will have the same frame size, and we will add a sub view to the SpriteKit view, and that will be the UI controller's view. And this is where the real magic happens, where we actually present the UI controller Swift UI view in the SpriteKit view. And this should already more or less work. So let's run it. So we can see the hello world here. But we do have a problem. If we change the size of the screen, it's a bit difficult to see. Just a sec. What we'll do is we'll make this one a bit larger and give it a foreground color that's a bit better, or a bit easier to see. So as you can see, when we resize the window, the SwiftUI more or less stays on the same page. And that's not what we want. We want it, if it's centered, to remain centered even if we change the screen size. So we need to do a bit more work for that, but it's not that much. So in our view controller, we can resize the UI when the view is resized. This also works, for instance, when you go into full screen mode. There is a function we can override, and that's ViewDidLayout. And here we should change the GUI view to the SpriteKit view. And to do so, we need a reference to this, to the GUI view. So what I will do is I will create an additional variable called GUI view. This will be of type NSView, and it will be an optional. And here where we add the subview, we will also set the GUI view to the UI controller view. So now we have a reference to the SwiftUI view, and here we can say GUI view dot frame equals the SK view dot frame. But there's a risk here because this function might get called before view did load, and then this the SK view might not have been set yet, as it's an implicitly unwrapped optional. So we promise that it should be the first time we're going to use it. So to be careful, what I'll do is I will check whether the GUI view and the SK view are already no longer nil. Otherwise we will return, then there's nothing to resize. So if we build and run, we should now notice that the SwiftUI view stays in the same place as the SpriteKit view. So that's nice and working well. But we're currently still only showing a static view, and it's more or less basically two completely independent things. And of course we want them to be together. So we want our SwiftUI view to represent the situation the game is in. So to do that, we need some way of gluing them together, and I like to use ViewModel for that. One option would be to simply take the game view and directly hook it up into the SwiftUI view, but some bit of abstraction in between can be nice later on. So we will create a new Swift file called ViewModel, and this will import SwiftUI, and it'll be a class, and it will conform to the observable object protocol. And this means that we can hook it into SwiftUI, and when this object is changed, the SwiftUI view will automatically change as well. So that's pretty easy to use. And what we want here is we want a reference to our world, because we want to represent the world state, and I'll make it a weak reference here, so we can be sure that we don't inadvertently create a reference cycle that we can't break, possibly leading to memory leaks. And we need published variables, and those are the things that when they change will trigger the GUI to update. So what I would like to store is a hover coordinate. That's basically the coordinate in world space where the mouse is over, and I want to have a hover tile. That's basically a tile that the tile type we're hovering over with the mouse, so the tile at the hover coordinate. I make them optional because, for instance, the mouse might be at a place where there is no coordinate or no tile. For instance, if it's outside of the SpriteKit view, it might be over the menu or over the window bar or outside the window. So that's the reason why we make them optional. And then what we can do, we can go into our GUI and we can add an observed object, and this will be a view model, and we will change this body a bit into, we will start with a Z-stack or a V-stack, so basically we're working from the top of the view to the bottom. We will use a spacer, so that's sort of adding white space, and then we want to have a horizontal stack of views that will form a line of information about what we're hovering about. So let's say if we have a coordinate set, then we can add some text called coord x, coord.y. Let's see, missing a parenthesis here. Let's see, so we have a coordinate, and we can add some padding, horizontal, and we'll use white as the foreground color. And this shows the coordinate if it has a value in the view model. We can also do the same for the tile. So we'll take a view model dot hover tile. We create a text for the tile dot raw value, that's a string, and this simply gives the tile type name. We can add some padding and again set the foreground color to white, and then we can add a spacer. This makes it that these are all on the left side. Now our preview also wants a view model because we added it as a variable here, so we can simply add a view model here, and we need to add the view model in the view controller as well because we need to initialize it here. So the question would be, where do you get your view model from? And I think the best way of getting the view model is from the GameScene. So what we'll do is we'll go into the GameScene, and the GameScene will have a view model, and then we can go into our view controller. We already have a scene here, so as the view model we will pass in the scene.viewModel. So we now also have a view model, and this should still build and run fine, but it won't show anything yet because we haven't decided to do anything concerning hovering yet. We're never setting the hover tile. So let's go into our game scene, and we will create a private function called hover, and this will set a hover state in the view model. And to do that, we will create a couple of helper functions called a vector to scene point. So we get in a vector and we get out a CGPoint, and then we take a CGPoint, that will be a CGFloat, or the vector x value cast as a CGFloat times the cell size, and a similar thing for the y value. And the other way around, we can have a scene point to vector. So this will take a scene point, and this will be a CGPoint, and this will return a vector. And the vector will have as the x value an integer for the cPoint.x divided by cell.cell size rounded. Let's see. Rounded to the nearest or away from 0. Let's see, I think I need one there. And something similar for the y value. So we create, and we cast as an integer. We take our scene point. Wait a sec. We first need to do this. Let's see. So let's get rid of the integer first. So we do the division. We do rounded to the. This should return a CGPoint, and this entire thing should be cast into an integer. And the same here. So we have a scene point dot y divided by the cell size. We round using the nearest or away from 0 rule. And we close this one, and then close this one, and then we have our vector. So we now can convert from screen space into vectors as used in the world, and the other way around. And we can now implement our hover method. Let's first start by getting the mouse position, and this equals to an NS event mouse location, and we need to subtract a value, the view window.frame.origin, because the mouse location is sort of in screen space. And depending on where your window is, you then get different values. And these are looking at scene space or sort of window space and not screen space. So we need to convert those two. Well, first, this is an optional. We will give it a default value of 0. And now we still get a complaint that we can't subtract CG points from one another. This is something I actually don't really understand why it's not available as a default. So, but what typically happens, I create an extension that does some math on CG points. So we can quickly implement this. Let's see, so we have an extension for CGPoint, and we will create a static function for addition, left hand side and the right hand side, and this returns a CGPoint, and we will return a CGPoint with the x value of the left hand side of x plus the right hand side of x, and the left hand side of y plus the right hand side of y. And we will do something similar for subtraction, and we can even do a negation. So we will take a point and return another CG point. So this will be a CG point minus point dot x and minus point dot y. So now if we go back to our game scene, we should be able to do this subtraction. Let's see, so we now have a mouse position in window space, not in screen space, and we need to convert this window space into a scene space, because the scene might be moved as we can move a camera. So we take the view and we convert the mouse position to ourself, and again we will give it the default value of 0, and we will create a hover vector. This will be the scene point, using the scene point to vector method we created, and then we can take the view model, and set a hover coordinate to this hover vector. And we can take a ViewModel and set a hover tile to world tiles hover vector. So we get a tile that's in the world position at a specific vector. Now to call this hover function, we take our update method and let's simply call it in every update. So every update we can see where the mouse is. And if I'm not mistaken, this should run and should allow us to show where we are. We are missing a parenthesis in the GUI. So it's not closing, not looking very well. So let's try again. So you can see that we have our, you can see the coordinate changing, and you can see that if we are over a tile, then the type of tile is shown in the bottom. And also we can see that once a tile has been set by the builder, it's actually directly updated in the GUI. And that's really the big advantage of using SwiftUI. It's very easy to make stuff that's automatically updated as value change. So that's it, what we're going to do today for SwiftUI. It's a really small start, but we can build on this way further. So next time, let's look at clicking stuff and then stuff happening as you click stuff using SwiftUI. So thanks for watching and have a good day.